All right, class, welcome. So this is 13.6, and I am recording this in 2020 for your benefit. And so we're going to look at the surface area of solids. So I just need you to have a general idea of how to do the surface area of pyramids, cones, and spheres. All right, so pyramids, cones, and spheres. And so let's get right into it. All right, so first off, the surface area of a pyramid. Now, every pyramid is different in that every pyramid, the base of the pyramid determines how many sides of lateral surface there is. So you have to be careful here. All right, so before we get into the formula of a pyramid, let's just get a general surface area formula. So I go area of a pyramid, PYR / cone. All right, so here's a general formula. It's going to be the area of the lateral surface. We saw that with the surface area of a cylinder and the surface area of a prism, right? But those figures had two bases. So it was plus 2 times the area of the base. Well, a pyramid and a cone only has one base. So it's plus area of the base. Now, this is the general formula for any cone or pyramid surface area. All right, so we're going to do the surface area of this pyramid. All right, hold on a second. I got to get this out of my way. Okay, good. And so we are going to do the surface area first off of a pyramid. Give myself a little bit more room there. Okay. Now, to help you guys understand, let me show you what happens when you take a pyramid that looks like this and you try to split it apart. Because remember, surface area is all areas of, so it would be the area of this base. Here I'm going to use some shading. This front lateral surface, right? Let me get rid of that. Here's this side lateral surface, right? Second. Notice it has a quadrilateral base. There's the third one, right? Can you picture that right there? It's kind of the back. Oh, I went too far down, right? I should have only gone that far down, right? The one in the back, the third. And then you have the fourth would be right there, right? Does that make sense? So we got to split this thing open. So let me do it this way. Here's the base, right? And notice we have the 6 there. And notice we have the 4 there. And we are going to have a triangle there, a triangle there, a triangle there, and a triangle there. Does that make sense? So the area of the base is a rectangle. And notice we have 4 triangles. Now, if our pyramid had a square base, all 4 triangles would be exactly the same. And that would be nice and easy. We would be happy because every triangle would be exactly the same. Now, in this example, it's a little bit different. So let me add in, you notice this 12 right here? So that would go right here, right? 12. And it would also be here, 12. It would also be here at 12. And it would also be there at 12. Okay? So the area of our pyramid is going to be the area of the base. I'm going to use black for the base. I'm sorry, area of the lateral surface is first. So I'll use black. There are 2 triangles of 1/2 base times height plus 2 more triangles of 1/2 base times height. And then plus the area of the base, which is a parallelogram, which would be base times height. All right, now that's a little tricky, but this is what you have to keep track of, and this is what's involved in this pyramid. All right, so area equals, and we got to sub in all these values here. I'm going to keep my 2's in black. The half By the way, let me do this. I don't even need that. Let's do some canceling. That 2 and that half would cancel. That 2 and that half would cancel. So I got to be careful now because I have two different triangles. So the first triangle is going to be with the base of 6 and a height of 12. And the second two triangles would have been with a base of 4 and a height of 12. So I hope that makes sense. Let me go back and I'll show you exactly what I mean using some color here. So taking a look at these two triangles, notice the base is 6 and the height is 12. Then the other two, and remember the 2's and the halves canceled out, would be here and here. So again, notice the base is 4, right? That's 4 and the height is 12. So that's how we got to here. So here was two of that's the top and bottom ones, and here are the left and right triangular lateral surfaces. Plus now I need the base and height of the base. All right, the base of the base is 6 and the height of the base is 4. All right, and so now I'm ready to multiply everything out. 6 times 12 is 72, 4 times 12 is 48. Keep this part in green, 4 times 6 is 24. So add all that up. The lateral surface, 72, 82, 92, 02, 112, and 8 more, 120, right? 120 and 24, 144 square units. We're doing surface area, right? Square units. And that would be the surface area of our rectangular pyramid. Now again, the pyramid could have a square base. So let me just go back. If the base would have been square, right here we would have done 4 because all 4 triangles would be exactly the same size. We would have done 4 times 1/2 base height. And then it would have been plus the area of the base, which would have been base times height, or actually for the base for a square, I could have just used side squared. So every triangle, every pyramid's a little bit different. When you get to geometry in your 9th or 10th grade years, you'll deal with even a polygonal base. So you can have a pyramid with a pentagon as a base, or a hexagon as a base, or a heptagon as a base, or an octagon as a base, etc., etc. And that's a little bit more complex, but it's the same concept. It's the area of lateral surface plus the area of the base. All right, so that's a pyramid. Now, cones are next, and they have their challenges as well. So a cone here, a little bit different scenario, and I chose one a little bit more difficult to use. But you're going to start with your general formula. The area of the cone equals the area of the lateral surface plus, because there's only one base, area of the base. Now to get specific, the base of a circle, the base of a cone is a circle, so we know the area of a circle is pi r squared. So there's the area of the base. Now what about this lateral surface? All right, now this is a little tricky, and I'm going to try to show you the cut open view. So when you cut open a cone, you get a circular base, but you also get this shape. And I know this won't make a whole lot of sense to you, but if you know, when I'm in class, I use some paper cutouts, and I get this kind of a shape, which is kind of weird. And it takes a little bit of time to develop the formula. Now, this isn't quite a triangle. So it's called a sector. And the area of this sector is pi times r times L, where L is right there. Okay? Pi times r times L. Okay? So that's what goes here. Now, that's something you just have to remember, and it's always pi RL. Pi RL, always, always, always. Okay, so now we're ready to find the surface area. So, some substitution. Pi is 3.14, or you can use your pi button. Now be careful. Notice the 10 millimeters is in the center of this dotted line going all the way across. That tells me the diameter is 10 millimeters, and so the radius would be 5 millimeters. Now I also need L. And notice I don't know L. I'll come back to that. Let's complete what we got. Here's another pi, another 3.14, and again, our radius, 5 millimeters squared. So right now, use some color here. I'm going to do this in keep it in red. I'm missing the L, the value of L. How am I going to find the value of L? How am I going to do that? What happens right there? What kind of shape do you get right there? Notice the right angle symbol there, so that means there's a right angle symbol there. Do you see the right triangle? Now, we know one side of the right triangle. That 12 millimeters is that value right there. And don't we know the value right here? Wouldn't it be the radius, or 5 millimeters for that side? So then can we find this side? And what would you use to find that side? So I'm thinking of a theorem, and an old Greek guy. Are you thinking Pythagoras? I hope so. The Pythagorean Theorem is what we want to use here. And so just to refresh your memory, Pythagorean Theorem, a squared plus b squared equals c squared. And remember, c is always the hypotenuse. Now, which side is the hypotenuse? The L, the 12 millimeters, or the 5 centimeters? 5 millimeters. And I hope you say the L, right? The L is the hypotenuse, always across from the right angle. Okay. So L squared is going to equal 12 millimeters squared, keep my units, plus 5 millimeters squared. But remember, we want to get all the way to L. So I'm going to take the square root of both sides. Okay. So now we have on the left the square root of 144 plus 25, and these are millimeters squared, and that equals L. Okay, 144, 154, 164, 169. Oh, that's very nice. What's the square root of 169? 13. What's the square root of millimeters squared? Remember, square roots undo squares, right? So you get millimeters, and there's our L. Perfect. So back in here, we go 13 millimeters. Okay. Now again, do your work in sections so I can see that you're getting parts correct. So what's the area of the lateral surface? 3.14, let's do, yep, 3.14 times the radius, 5 millimeters, times the L, 13 millimeters. And for this part here, let me stay in red. For this part, I got 204.1 millimeters times millimeters, or millimeters squared. Okay, on the back part, for the area of the base, I got to square my 5, so that's 25 times 3.14. Again, we're rounding off here, and this is 78.5 millimeters squared. So our area is approximately 282.6 millimeters squared of surface area. So what did we find? We found the area of the base plus all the area of the lateral surface. And that's surface area of a cone. All right, again, so general formula, but for a cone, what's the biggest key is understanding the area of the lateral surface is pi times r times L. At this point in your math, it's to your advantage just to memorize that, because to derive it is complex, and therefore then the easier way is just to memorize the pi r L. Okay, so there's area of a cone. Let's get down to area of a sphere. All right, and you'll like this. Area of a sphere is way easier than all the rest. Okay, so let's figure out the area of the sphere. Notice I included a radius here of 4,000 miles. That should mean something to you. A radius of 4,000 miles. 4,000 miles is roughly the radius of the Earth. So 4,000 mile radius is roughly the radius of the Earth. So we're going to figure out the surface area of the Earth. Now, you need a formula. All right, surface area. And by the way, I should have said this all along. Some like to use SA for surface area. So that's fine. I don't have any problem with SA, but if you see SA, it's talking about surface area. But again, how else do you get the area of a sphere? Well, it's got to be the surface area. That's the only area you can talk about when you're talking about a three-dimensional figure like a sphere. Again, any three-dimensional figure, a cone, three-dimensional, you're talking surface area. A pyramid, three-dimensional, you're talking surface area. A prism, three-dimensional, you're talking surface area. A cube, which is a prism, three-dimensional, you're talking surface area. A cylinder, three-dimensional, you're talking surface area. Got it? But again, some will use capital S, capital A. Now, again, why do I use the subscript? Because I'm trying to help your brain keep track of all the different area formulas, right? It's just a brain help to do the SPH for sphere. You can write it out if you want, SPHERE if you want. Okay, this formula is pretty simplistic. So think about the formula for area of a sphere. And it's pi, or area of a sphere, area of a circle. So what's the formula for area of a circle? Pi r squared. Okay, all you need is one other number times it, and that's the formula. And it's the number, and think about it. Think about, watch, I don't know if this will help you. If we go like that, we slice it here, and we slice it there. How many pieces do you get? Right? How many pieces do you get? I know that's weird, but you would get 1, 2, 3, 4 pieces, and that number is a 4. So there's the formula for area of a sphere, 4 pi r squared. Makes it quite easy to do these problems. So what is the area, surface area of the Earth? Well, 4. I'm going to use my pi button here, so I'm going to leave pi as pi. I want to get a little bit more accurate. But again, the 4,000 is a round off on the radius. So the radius of the Earth, roughly 4,000 miles. It is a bit of a round off. So 4,000 miles squared. Let's see what we get. So evaluate all exponents first. 4,000 squared times pi, or 4, then times the 4 pi, whichever order you did it in. Excuse me. Okay, so this is going to be approximately, let me see my decimal places, 1, 2, 3, 1, 2, 3, 201,061,929.8 square miles. 201,061,929.8 square miles. All right, approximately. And that would be the surface area of the Earth. Want to find the surface area of a sphere? No problem. 4 pi r squared. Okay, so we start off with a pyramid. So be careful. You got to be careful with the lateral surfaces. You're going to get these triangles when you split it open. And if it's a square base, it's going to be 4. If it's non-square, a rectangular base, you got to do 2 and 2, because 2 of the triangles, once again, 2 of the triangles will be the same side, and the opposite 2 triangles will be the same size. All right, so 2 and 2. And then area of a cone, area of the lateral surface is always pi RL, that's the key, plus area of the base, always a circular base. Okay, so that is surface area of a pyramid, a cone, and a sphere. So again, my goal here in pre-algebra gets you to generally understand the main concepts of the surface area, and you'll deal with this in great detail in geometry class. All right, that's the lesson.